Okay, please put your pencil down, and now it's time to see how we did, and if any mistakes were made, to learn from them. Of course, you already titled the lesson, Lesson 4.6. You can already see what our objectives are for today, but we are going to warm up with some material that we are supposed to already have mastered. Before I reveal my proof and hear about your proofs, I'd like to ask a couple of questions. My first question is, how many statements total did you have in your proof? So if you would look at your last statement, because they're all numbered, you should be able to quickly tell me how many you have. So what I would like you to do is, using one or two hands, hold up the number of fingers that represents how many statements you used. Please do that now. Keep your hands up and look around. Okay, put your hands down. Now I would like you to look at your very last statement, and I would like you to look at the reason for that last statement. What was your reason? I would like to know the reason for your last statement. Eric, John, Nathaniel, Kadir. Eric, what was your reason?
SAS.
Okay. 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 Kamoy, you also were volunteering. What was your reason for your last statement? Okay. So if you want to use SAS, how many pieces of concrete evidence do you have to have laid out within your proof to then be able to say SAS? Stephanie? 3. What are the 3 pieces of concrete evidence that you must have? In a general sense, not specifically for this. Sharik?
2 sides and the angle that they form.
I love the way you said that. That was very well said. 2 sides and the angle that they form. So now look at your proof and see if you were able to accomplish that. All right, so I'm going to reveal my proof. And then don't mark yours right or wrong. Just compare, digest for a few moments, and then we'll talk about some critical pieces that had to be there. So I took 8 steps. I could have condensed it down into 7 probably. So 5 people agreed on SAS congruence postulate as the reason for the last statement. So you had a goal in mind. Throughout the proof, you needed to lay out 2 sides being congruent, another 2 sides being congruent, and then the angle that they form being congruent. Well, 2 out of the 3 are at the crime scene. I'm sorry, 1 out of the 3 is at the crime scene. So we've got right there at the crime scene. So there's the angle. So now we need the sides that form that angle. Those angles. Which means we need this side here, and we need that side and that side. So the side in the middle was easy. You should be getting pretty used to that. And so there's an easy piece of evidence to find because of the reflexive property. So that's 2 out of the 3. And as I walked around, I saw a lot of you on the right track with the 3rd piece of evidence, but some of you omitted something that was really important. These 4 steps right here are all needed to establish that last piece of evidence. And many of you omitted, in mine, it's statement number 5. On yours, it might be a different number. I had a lot of students who had this statement, and then you jumped to this one. But you did not support that. If you have these two statements, these are not equal to each other. There's nothing about these two statements that indicate that they are equal to each other. It is not until you take this given information and substitute here that now you end up with statements 3 and 5. So if you look at statement 3, I changed statement 4 into statement 5 using substitution and using this information here. Now I have, this side is now the same as this side. Now I can say that is equal to that, right there. So yeah, there was some work to be done. 4 statements just to establish one piece of evidence. But that's the nature of geometry honors. That's the nature of writing a proof. So, before I have you give yourself a score, are there any comments or questions about what you did and whether or not maybe it's acceptable? Eric?
You know how it says, it just says equal to?
Yeah.
Would it be fine if I turned it to say congruent?
Well, I'm actually glad you brought that up, because in actuality, you are right and I'm actually wrong. I made a mistake, and it was pointed out by one of your peers in the other class. I unfortunately didn't have a chance to correct my mistake, and I actually thought it might be valuable to show you the mistake. The information that's given is in the form of values. That's a value with an equal sign and a value. But notice what this is. This is congruence. And SAS is a congruence postulate, which means you need objects congruent to each other, not lengths. So I actually made a mistake. I actually needed to do what you did. So you get bonus point above and beyond what I did. Because I would give myself a 4, although I realize now maybe I would need to give myself a 3 because I did some errors in how I wrote things. You get bonus point because yours is a 4, but then you also pointed out a mistake that the teacher made, and that gets you bonus point. Okay? So, does anyone have any questions on what we're talking about? Because here I needed to write segment LN is congruent to segment JN. I didn't write that. So that was an omission that's not acceptable. I did have the correct statement here. I would even go as far as to say this needed to be changed from measurements to objects. So I have some mistakes. So thank you for pointing that out. Any other comments, questions? Okay, well, you have a copy of the rubric in your notebook, and it's also right there. So go ahead and give yourself a score from 0 to 4 on today's warm-up. All right, let's hit the pause button. And so everyone should have a slip. Let's see which group I am grading today. I'm grading Group E. Group E, please bring your work up to me. Everybody else, you're going to trade within your group. Very nicely done. Yeah, that's fine. Yeah, absolutely. Absolutely. And Eric, after you get yours graded, could you bring it up to me, please?
Okay, so
Good?
yeah.
Give
Yeah.
yourself that when you get finished. That's fine, Joe. Eric, when yours is done getting graded, bring it up to me, please.
Okay.
Like, Eric, you don't have to bring it up to me after.
Yes.
You don't have to bring it up to me. Who's got Eric's? Okay, I'm gonna get your scores from you. Staple it. Where's staplers? You guys can always just come up and get a stapler. You don't have to wait for me. Unless, of course, I'm completely out of staples. You certainly can say. Can't
What?
I am literally down to scraps of staples. So I will get some new ones as soon as I can. All right, so the objectives for today are up on the board. Take a moment to digest those while I call out your name and get your score. Sharif,
9.
Alexandra,
8.
Eric,
9.
Stephanie T,
8.
Kayla,
8.
Matthew,
8.
Kadir,
8.
Stephanie R, Dayanara, Shimara,
8.
Valerie, were you able to do it or you didn't? You did, okay. Very good. John, spoke to you, Kalasia, Extol. Extol, you brought me one.
Yeah, that was 2.
What was the score?
8.
That was 4.4.
Yeah.
Okay, thank you. Sebastian,
8.
Moy,
8.
Steven,
8.
Daniel, Kate, so far, this chapter, with the exception of one lesson, we have been building a toolbox of investigative techniques, ways for you to prove things to be true. And I've been using this analogy constantly between the criminal justice system and the legal system and our little world of geometry honors here. And I like the analogy, and I feel like it's working, and it works for me. So I'm going to continue doing that. The point is that, again, we're just arming ourselves with different ways of proving things. So you already know a number of different ways. You know side, side, side. You know side, angle, side. You know HL. So you have different ways of proving things. Plus you have other ways of finding evidence, like vertical angles and alternate interior angles, alternate exterior angles. You have an entire, very large at this point, toolbox of ways of finding evidence and proving things. And we are going to just add to that today. So you can see the title of today's lesson, Prove Triangles Congruent by ASA and AAS. You could guess what those meant, because you already know what S stands for and you already know what A stands for. So our objectives for today are to be able to apply angle, side, angle, and angle, angle, side, and to prove triangles congruent using them. Some new vocabulary. I put this out there last time, but now you're going to see it in particular today, included side. So let's go ahead and look at the postulate and the theorem of the day. So, you have this on your cheat sheet, so there's nothing to write down, but you have to know it. Angle, side, angle says that if you have two angles in one triangle congruent to two angles in another triangle, and their included sides are also congruent, then you can say that the triangles are congruent. So, included side is a really important component. It has to be the side that's connecting the two angles. And that's angle, side, angle. I also want you to note that this is a postulate. A postulate is something that we just know to be true, and you could just use it right away. Any questions about that so far? Second one's a little bit different. Angle, angle, side, congruence theorem. It's a theorem because we actually need angle, side, angle to prove it. This would not exist without this here. And sometimes when I introduce a theorem, I tell you guys that you can just start using it right away and you don't have to prove it. Today, I'm going to say the opposite. Today, you may not use angle, angle, side until we prove it. Okay? So what does angle, angle, side say? It says that if you have two angles in one triangle congruent to two angles in another, and a non-included side is also congruent, then the two triangles are congruent. So here, this is the non-included side. Look at the picture up here. This is the included side. But now I'm saying angle, angle, side says it doesn't have to be that. It could be the non-included side. In fact, if you could show this side was congruent to this one, you could do it that way as well. Any questions about just the definitions of these, the postulate and the theorem? All right, we're going to jump right in and start using angle, side, angle. So we're going to jump in with a proof. Example 1. And you do need a sketch of the picture. This is not the time to pick up the ruler and draw a perfect picture. This is the time to jot down the given and the proof statement and to sketch the picture. All right. So everything that's written in the given statement is also indicated in the diagram. And we're asked to prove the two triangles are congruent. Now let's rewind for a moment and let's go way back to side, side, side. With side, 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 how many concrete pieces of evidence do you need to prove it, to use it? Caleb? 3. With side, angle, side, how many concrete pieces of evidence do you need to use it to prove your case? John?
3.
With hypotenuse leg, HL, how many pieces of evidence do you need to be able to use it to prove your case? Kamoy? 3. With angle, side, angle, how many pieces of concrete evidence do you need to use it to prove your case? Nathaniel? Sorry? 3. We need 3. We need angle, a side, and an angle. So, look at the diagram. Could someone tell us what we've got so far? What do we have so far? Stephanie? So out of the 3 pieces of concrete evidence, we already have 2 of them. So we already are given this is congruent to this, and this is congruent to that. I'm asking that we use angle, side, angle. So we need a third piece of evidence. The third piece of evidence is what? A side or an angle? Kadir? Okay. Which angle? Now look at the picture either that you drew or look up here. Which angles must we use? Alexandra? Okay. So it has to be this and this, because for angle, side, angle to work, the side has to be the included side. So that would mean we have to prove this congruent to that. So right now I'm just talking about path of logic. We've got 2 pieces of evidence at the crime scene. We already got them. They're right here. We need the third piece. So now we have to be an investigator. Any questions so far? Good. You now have 1 minute with your investigative team to try and come up with a way to prove angle R is congruent to angle V. That is your goal as your investigative team. Go. Remember, you're not allowed to use angle, angle, side yet, so we can't use that. Has to be angle R and angle V. You might want to use your cheat sheet. Okay, give me a thumbs up if you think you and your investigative team have found a way to prove it. Okay, one team is semi-confident, another team semi. Okay, 1 more minute of investigative time. 1 more minute. You guys got to come up with it. I'm going to check with the group who thinks they've got it. I'll be with you in a minute. Okay.
Alright. See, these are variable angles, right? And they're totally. We use a third angle.
So what would have to be true for us to use all these?
No, that's not very easy. Our I know, but the third angles tend to triangles that come to a two, and R and third will become two. So the
What do they think?
Third angles there.
Okay. Okay. So now give me a thumbs up if you and your investigative team have discovered a way to prove it. I also have some individuals who think they've proven it and their team didn't quite get what they were trying to say. That's okay. Okay, put your thumbs down. All right, we'll start with Kamoy, Kadir, and then Eric. Kamoy, what are you going to do to prove that angle R is congruent to angle V? Okay, that is absolutely true, so let me indicate that. Okay, so what was that last reason that you used? Absolutely. So this angle is congruent to this one, this is congruent to this one, so now we have two angles in one triangle congruent to two angles in another. The third angles theorem says that the third angles will automatically be congruent. And so we have proven it using that technique. Eric, I apologize she stole your thunder, but you also just proposed that idea to me as well. Almost exactly word for word, is that correct? Good. There was somebody else who was also in the mix. Kadir, what was yours? Same thing. Okay. Good. Anyone have a different technique that they discovered? Because there is another way. Okay. Well, let's stick with this method then for now. So now we need to use what we learned to lay out the proof. So, get your table set up if it's not set up already. We'll start with statement number 1 and lay out the given that angle S is congruent to angle U and that segment RS is congruent to segment VU, and that is given. And as we stated way back at the beginning, that's crime scene evidence. That's right there laid out for us. That's 2 out of the 3 concrete pieces of evidence. But now we have to use our investigative abilities to get to the third piece. And Kamoy laid it out for us perfectly. Statement number 2, we need to say that these two are vertical angles and are congruent. So you could say angle RTS is congruent. Let me make sure I get my letters correct. RTS would have to be VTU because of the vertical angles congruence theorem. So we can just say vertical angles congruence. Now that is not a concrete, direct piece of evidence, but that leads us to the next piece, which is the third angles theorem. In statement number 3, we can now say that angle R is congruent to angle T. I'm sorry, to angle V. I apologize. Because of the third angles theorem. Now, double check and make sure we've got our 3 pieces of evidence that we need. This is angle, side, angle. So now our last statement can be that they are congruent triangles because of angle, side. So if you group things well, it's really just a four-statement proof. Not terribly difficult. But the logic is the hard part. It was statements 2 and 3 that you really had to work hard at figuring out. Any questions, concerns, any issues? So Alexandra, you had said when Eric had proposed it that it didn't make sense. Was it that it was just...
So I can word it.
Okay, maybe just the way you worded it. It makes sense to you now?
Yeah.
Okay. And do you see, and I'm not just talking to Alexandra, I'm really talking to everybody. Do you see how the chain of evidence, the chain of logic, proving this then allows you to prove that, and that's what we were looking for? Okay, good. Any comments, questions? Okay, so let's look at angle side angle from a slightly different perspective. Example 1b, part B of the same example. Determine if we can use angle side angle to prove these two triangles are congruent. So really, I am asking a yes or no question. Yes, we could use angle side angle, or no, we cannot use angle side angle. So I would do a sketch of the picture. In this case, we have a set of parallel lines. So I would make sure you drew on your graph paper, or if you're just using notebook paper, make sure you use the lines on the paper to help you a little bit. Your picture doesn't need to be perfect, but label it accurately and draw it to the best of your ability. And then I'm going to give you time with your investigative team again. I'm going to give you 2 minutes this time, and at the end of the 2 minutes, I want a simple conclusion. I either want, yes, you can use angle side angle to prove them congruent, or no, you cannot. But if you are, as a team, going to say yes, you have to be able to tell me the chain of logic, just like Kamoy, Eric, and Kadir were ready to do in the previous proof. They were able to say, oh, first show that the vertical angles are congruent, then using the third angles theorem, we can show those are congruent, and then so that we have all the evidence. So I'm not going to ask you to write out a proof, but you have to be able to say why it will work. If you are going to say no, it can't be used, then you need to be able to say what's missing. You could say, oh, well, we have angle and angle, but we don't have a side. Or, oh, we've got side, side, but we're missing an angle. Okay? And I am not asking you to use any other postulates or theorems. I want you to only show that you can or cannot use angle side angle. Does anyone have any questions about your goal for the next 2 minutes? Okay, you got 2 minutes to investigate. Go ahead.
Okay, that's side. That's the first side. Okay. 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 That's okay. Okay. Makes sense.
Well, yeah.
What? Using interior.
Like it's aligned with our one.
I get it. You got it?
You have about 40 seconds. When the time is up, you need to be able to say as a team yes or no and have support either way. All right. So first, I would like to survey the teams to find out your opinion. So you're going to give me a thumbs up if you and your team, and so the whole team needs to give me a thumbs up, if you and your team think that we can prove them to be congruent using ASA. So give me a thumbs up. Okay, I got 1 team, 2 teams, 3 teams, and 4 teams. Okay, put your thumbs down. 2 teams say no, I assume, because you didn't put your thumbs up. Okay, so Nathaniel, you were on a team that said no, you cannot. We need 3 concrete pieces of evidence. We need angle, side, and angle. What's missing?
Well, we had a lot of trouble finding the angles.
Okay, had a lot of trouble. Were you able to find a side?
Yes, the side is
What side did you find?
NM KL. The second NM is going to 7 KL.
How could you prove that? I'm not saying you're right or wrong. I'm asking how do you prove that? Don't abandon all hope. I'm just saying.
That was my choice. It was L. Side LM is going to be
Okay. So because of the reflexive property of congruence, we can say that that is congruent to itself. So using ASA, we've got the side. But you said you and your team had trouble finding the angles. And if that's the side we're using, that means that we need to somehow show this is congruent to this, and that this is congruent to that because of the way the shape is. That's the way it would have to be. So let me rewind and let's see what we figured out. Okay? So let's go to Stephen. You were on a team that felt that you could prove them congruent using ASA. Do you agree with the side that Nathaniel proposed? Okay. So now we need an angle. Can you give me one angle that's congruent to another?
The inside of
L, M,
No,
N.
L, N.
L, N, M.
Yeah,
Okay.
the inside of it.
Well, you don't have to say inside. You just say L, N, M. That's this
Yeah.
angle right here.
It's congruent to K, L.
K, L, N.
Yeah.
You say that those two are congruent. How could you prove that? Alternate interior angles. Ziomara and Excel, you agreed with that? Okay. I will absolutely buy that. That is correct. This is functioning as a transversal. These two are parallel. This is alternate interior angles. They are congruent to each other. So we have angle as well. So we're on our way. So Sharik, you were on a team, I believe, that said you could prove it, correct? Do you agree with the evidence that's been proposed so far? The side is one piece of evidence, and the angles being congruent is the second piece of evidence. Do you agree? So then you need to find us the third piece of evidence, the third angle, the other angle. So what is it?
It's angle MLN.
Hold on. LMN. This angle right here.
No, MLN.
MLN. MLN. So this angle right here.
Yes.
Okay.
Congruent to K and L.
K and L, you're saying those are congruent. Okay, how can you say that?
Because since those two lines are parallel, you can use the alternate interior angles alternate interior angles theorem to prove that those two are congruent.
Actually, we can't because this line is parallel to this one, which makes the blue line that I drew, those two arc marks, those are congruent. If we wanted to use alternate interior angles, we would need these two to be parallel to say that those were alternate interior.
No, like I mean the line LN would be like the transversal from the.
I understand what you're saying. LN is the transversal, but we now would need this parallel to that for this to be congruent to that. Let me show you. You're trying to say those two angles are, you're trying to say this is alternate interior, right? This is what the picture then has to look like. That's alternate interior. But for that to be true, this line has to be parallel to that one. Is that evident in the picture? No, it is not. So unfortunately, we cannot say by that reason that those two are congruent. Maybe there's another reason, but that can't be the reason. John?
Put angles M and K.
So you want to say that this is congruent to that?
Yeah.
How come? But alternate interior angles is based on a transversal. If you wanted alternate interior angles, this angle, this would be the transversal, and then this angle over here would be congruent to that one. But there is no angle over there, so unfortunately that's not alternate interior. Okay, Kadir?
Can you say like same side, like consecutive?
Same side. Well, that would be this angle here and that angle there were supplementary. I don't know, maybe there's a chain of logic that can get you there. Go ahead, Sharif.
Can I think about you know how the angles from L and N are congruent, right? So
Okay, well, I'm going to cut this off. There may be a roundabout way to do it. Kadir gave me something to think about that maybe I'll try. But from what I can tell, you cannot use ASA to prove these two triangles congruent. You cannot because we're missing one angle congruence. We're missing one angle congruence, so we can't use this postulate to do it. Okay? Come on. I'm sorry. Kadir said that he asked if you could use consecutive interior or same side interior, which would be this and this are supplementary. And I'm sort of wondering if there's somehow to say that and somehow do some subtraction or something that could actually prove it. But I'm gonna have to do some of the grunt work to see if I can figure it out. Consecutive interior? Yeah, I don't know if we can prove that absolutely to be true. That's my question. I totally get what you're saying. I just don't know if we can actually prove it. Okay? So we'll come back to it, but initially I would say no, you can't. Okay? So we spent a bit of time on ASA, getting to know it, learning how to use it within our toolbox. Any questions? Good. So checkpoint number 1, I would like you to prove that triangle ABE is congruent to triangle ADE, given this information. I'm going to put 5 minutes on the clock. At any point you would like to talk to your teammates about something, you can do it quietly. This is not official team talk time, but if you want to check a thought or something like that, you're more than welcome to. Give me a thumbs up if you have a full. Good, that's what I expected. You can put your thumbs down. I'm going to do something that I don't usually do. I'm going to hit the pause button on this checkpoint. So what I want you to do, because we're going to come back to it, it's actually a beast of a proof. It's not super difficult, but takes quite a few statements to get the evidence you need. So what I'd like you to do is leave a few lines of space. If you have a table, like you should for your proof, definitely leave. I'll give you a hint. Mine's got, I probably could have condensed it down to 10, but I have 12 statements. I probably could have gotten it down to 10. I definitely could have gotten it down to 10. Okay? So I want you to feel the success because it is actually very interesting to see the result of this one. But what I want to do is I want to finish the lesson because we have angle, angle, side, which we haven't talked about yet, which is going to be faster than the first part. I want to address that, and then we're going to come back to this, okay? So we're just pausing on this. I'm not skipping it, and I'm not eliminating it. So leave a couple of lines of space and come to example 2. But I don't want you to write anything. I just want you to look. So I told you at the beginning of the lesson that I was not going to allow you to use angle, angle, side until we proved it. So we're going to do that right now. And I actually have this screen set up to do a formal proof. However, what you didn't realize is we actually already proved it. So we're going to use this page here to just point out how we did. We actually proved angle, angle, side when we did example number 1A. So now I want you to look at the picture I have here. This picture. Let me get this out of the way. This picture right here. We would like to be able to say that these two triangles are congruent. Angle, angle, side says that they are, but we haven't proven it yet. So what was the missing piece that 3 of your classmates pointed out that allowed us to say angle, side, angle? There was something we did in example 1A that allowed us to say angle, side, angle. So you might need to look back. There was a key piece of evidence that was discovered by 3 of your classmates. Okay, even if you don't think of them, just look at what we have here. What other piece of information would we need to be able to say that the 2 triangles are congruent? Got 4 light bulbs, 5 light bulbs. Ziomara, what do you think? It is the third angles theorem. That was the turning point in example 1. If you have 2 angles in one triangle congruent to 2 angles in another, then the third angles theorem says that the third angles will automatically be congruent. And then we have angle, side, angle. Right? Now we have angle, side, angle, and we're allowed to say that the 2 triangles are congruent because of ASA. But now we have a shortcut. We can now say angle, angle, side, because that's going to be true every time, no matter what 2 triangles we have. If we have 2 triangles that have 2 angles congruent to 2 angles, then the third angles will always be congruent. And if we have a side congruent, then it will always work. So we have actually already proven angle, angle, side. And so from now on, you may use angle, angle, side, or angle, side, angle, or any of the other methods that you've learned. Okay? So the critical piece was the third angles theorem. Does anyone have any questions about that? So now, based on that, and what you've learned so far today, I'm going to give you a different checkpoint that's totally different style. So, and somehow my labeling got a little messed up. This is A, and this is B. And so here's what we're going to do. Here's what you're going to do. Tell whether the pair of triangles can be proven congruent by any of the postulates or theorems you know so far. You may use SAS, ASA, SSS, AAS, or HL. So, I first want you to say yes or no, and if you say yes, tell me which of these you can use to prove it congruent. If you say no, then you write not necessarily congruent. Okay? So you've got 2 different diagrams, 2 different problems you need to do. You got 4 minutes on the clock, that's 2 minutes per. More than enough time. And again, your goal is to be able to tell me whether or not you can prove them congruent and what reason you can give. Kamoy, go ahead. Yep, if you can figure out 2 different ways, that would be even better.
It has to be including angle, not just two sides. We need more info. We just have to find and not how do you know them? Because not so necessary.
Oh, yeah.
The one side is obviously that by having line. So if you don't do
Not necessarily.
you want to not included in, not included in, this is a good angle, the good angle, that's
Oh, yeah, they said. Oh, yay.
All right, let's see what you figured out.
then it's not complete.
So first, let's survey for part A. Give me a thumbs up if you think you can prove them to be congruent. A lot of people think they can be. A lot of you think they can be. Okay, put your thumbs down. Stephanie T, what reason do you think you could give? Angle side angle. Okay. Alexandra, what reason do you think? You agreed as well. Okay. Dianara, I'm sorry, I didn't know just if your thumb was up. Did you agree that we could prove this? ASA. Okay. So this could be proved by ASA. Did anyone find a different way of proving it? Sharik? Angle, angle, side. Okay. And if that were the case, then it would have to be angle, angle, and then this side, or angle, angle, and this side. How could you show this side congruent to that one?
I put the diagonal side as usual. I have one of the angles from those two angles that give me congruent. But you can prove the third angle using the third angle theorem.
Ah, yes, you're right. Yep, you are absolutely correct. So I forgot about that. You're absolutely correct. Using the third angles theorem, you can say that this is congruent to this, and then you could say angle, angle, side. Absolutely. So thank you for pointing that out. Angle, angle, side. Great job. Let's look at part B. Give me a thumbs up if you felt like part B could be proven. Okay. Couple people up here. A lot of people say no. A few people say yes. Kalasia, you say no. Couldn't find any way to prove it? Well, she's correct. There is not necessarily enough evidence to prove it. We would need to be told something like the vertical line is perpendicular to the horizontal line or something like that. But we don't have enough evidence. We have side-side angle, but there's no such thing as side-side angle. So we do not have enough information in this case to prove them congruent. Does anyone have any questions or comments?
The first one, Another way it could be AAS is because of the alternate interior angles converse theorem, where the two lines are parallel, and that would be an angle, and a side.
Okay, so you actually came up just now with the other way to prove this one. Because using the converse, nothing here says that they're parallel. But because this is congruent to this, using the converse, you can now say that this is parallel to that. And so he's now applying it again here. And because this is congruent to this, that makes this a transversal, and he has shown that that is parallel to that. And now you can do a whole bunch of different things from that. That's an outstanding deduction that you just made. Okay? Great job. Any comments, questions? Okay? We are going to get back to the other checkpoint, but I would like to give you your homework. Your homework is on page 250, numbers 3 through 20. And number 33, which is a 4-point proof, and number 34, which is a 4-point proof. It's a total of 26 points. I would like you to do the at-home tutor for lesson 4.7 or read the next section. And you will have a quiz next week. It will be in the latter part of the week. I'm not exactly sure what will be on it, but I will let you know right when I see you early in the week. Just make sure that you start making sure you know all 5 of the different techniques you know for proving triangles congruent.